In this video, what I want to talk about is just another type of standardized score called the T-score. T-scores are widely used to report performance. You see them on standardized tests, and you see them on other different types of inventories. And I just want to make sure you understand what they are. Let me just start with how we calculate the T-score, and then we'll kind of come back to this. But a T-score is T sub I, so for any ith T-score, is going to equal 50 plus 10 multiplied by the z-score, or the ith z-score. Let me write that a little bit neater. Let's try that a little bit neater. Zi. And so essentially what you're then starting with is 50 as the mean and then weighting the z-score by a factor of 10. So let me kind of show you what we're thinking, the logic behind this. So if I go down my middle point, this is going to be my traditional standard score in the middle point of 0, a z-score of 0. And I can go out to plus 1 standard deviations, plus 2 standard deviations, plus 3 standard deviations, so on and so forth. Just to be consistent, let me go -1, -2, -3. So again, about 65 to 68%, plus or minus 1, almost 95% plus or minus 2 standard deviations is what we're capturing. Okay, this is kind of a review here. Why was the T-score kind of invented, and why do we use it? Well, it's very difficult to explain to somebody that you scored at the mean and your z-score is a 0. It has kind of a negative connotation. So essentially, then what measurement folks have done is just created a new scale and just rescaled it so that a mean, instead of being a standardized score of 0, the mean now becomes 50. One standard deviation above becomes a t-score of 60. Two standard deviations above becomes a t-score of 70. Three standard deviations is a t-score of 80. Taking the same logic then, if you're one standard deviation below the mean, it'd be a t-score equal to 40. Two standard deviations would be a t-score of 30. Three standard deviations below the mean would be then a t-score of 20. And so if you scored right at the mean, notice that you'd be taking 10, multiplying it by a z of 0, which would cancel out that term, so you would get 50 as the mean. So taking again our data set from the year's employment, our mean was 6, our standard deviation was 2.71, and as we went through this, we used my X raw score of 9 years. If we wanted to put the units in, these are all in years. And so for me, a z-score from my 9 years of employment was equal to, again, 9 minus 6 divided by 2.71. This is all in years, gives me my unitless z-score of positive 1.11. We plot that down here, and we go into 0. Let's call that 1.11. 1.11. So that's my z. Okay, let's convert that then to a t-score. So my t, equivalent t, would be 50 plus 10 multiplied by a z of 1.11. So if you reduce this expression right here, you'll get 11.1, and you'll get 50 plus this. So t equals 50 plus 11.11, which will equal 61.1. So my equivalent t-score would be positive 61.1. And so you can see how that would essentially line up right here with my z-score of 1.11. So that's it for T-score. It is just another way to scale scores, and again, the advantage to it is you do not have to explain a zero here. The middle mark of 50, for whatever reason, just has kind of a better feeling to it. So a lot of times when we're using scores and then trying to explain where people fall to the lay public, a lot of times you'll see T-scores instead of Z-scores, so you can kind of avoid the whole explaining the zero issue. That's the intuition behind the T-score. I hope you enjoyed the video.